So we're going to do we'll start by doing the first problem in Lab 6. But I've lost network connection here. Well, we don't need that page as long as someone can remember what the number is. It's a circle drawing problem, right? Does someone have that open? Huh? Oh, it's back. It's back. Okay, here it is, Lab 6, 419. So let's look at what 419 is asking. I think what it does is it asks for, the purpose of the exercise is to calculate the area of a circle. Is that right? A circle that the user draws on the screen. Did I get that right? Because I don't have the statement in front of me. Okay? Is that right, Ati? Do you know? Okay. Yeah. I see. So it was the area and the perimeter? Oh, okay. All right, so let's see, it's 419. Let's go ahead and do that. I'm going to go through the process of creating a project again in Visual Studio. So I'm going to add a new project. This is a graphics window problem. So it's P, what was the number again? Wait, I have it here. 419. Okay. I'm going to remove these folders because we don't have a lot of files to manage. We don't need those. And one thing you need to remember in Visual Studio is to turn off Unicode. Let's go down to the project properties. You only do this because the author's libraries don't work correctly with this default setting. Normally, you would not turn this off. All right, let's get the boilerplate code to start with. Let's see. That's under lectures. No, not lectures. Notes. Hello graphics program. So let's add a main. Let's add a CPP file that has the main function in it, which is the entry point. Actually, it's not called main, it's called CCC winMain. And we need to get the supporting files. Let's go ahead and do that. Let's see. Here they are. I'm going to copy those into the new projects folder. Let's add those. Oops. Add existing item. We'll save this. This include, you can see it's underlined, but it should disappear in a second. Well, maybe we don't want to wait for that. Let's go ahead and build. Oh, this is the wrong header file. This is CWin? Is that right? That's not there. Wait, it's right here. msw.h. Okay. Now these, I believe these should disappear. So there we go. We have that in the background. Visual Studio is trying to build the code that we have in the editor. And so if it finds a syntax error, then it tries to identify that with the red underline. All right, so this, let's just check to see if it works. And this is another program. So I could right click on here and run this. It's out of date. Why is that out of date? Maybe this didn't build. Did this not build? Right click on that, debug, start new instance. Looks okay. There's the point. I'm going to set this as the startup project just to make it easier to run. Okay, at this point we really don't need to see that anymore. Now let's solve the problem. And this problem appears in chapter 4, so you know that it involves functions. Does the book actually ask for or give you the function headers or the function prototypes? Does it describe what the functions look like in the book? Can I see the book statement? Does it give any information about what the function should look like? It does. It says write functions, double perimeter, circle C, double area, circle C, right? It gives them to you. You don't have to think of these. So you just, let's go ahead and do that. So it's double perimeter, double area, circle C. Okay. Let's put them in there. Double perimeter, circle C, double area, circle C, so this function here called perimeter takes a single argument which is of type circle, and when the function completes it returns a double precision floating point number. It returns a number. When area runs, we pass in a circle. We pass in a circle. The function runs, it computes the area of the circle, and then it returns the area as a number to the calling code. So the calling code would look something like this. So we have to have a circle. If we have a circle, we pass it into the function. We call the function, pass in our circle. The function returns a number, and we use the assignment operator to store the number in this variable called area of circle. So now we have a red underline here. That's because circle is undefined. Let's just hover over that error. Identifier, circle is undefined. We did not define it. We're using a word or an identifier that the compiler doesn't understand. It hasn't been defined. Let's define it. Circle, circle. Can we do that? I don't think that's going to work. This is called a constructor that takes no arguments, but they don't have such a thing. So the circle takes a point for the center. We'll put the point at the center of the window. And it takes a radius. Look at this. Visual Studio is showing us some alternatives here. And this is the one that we're going to use. The circle has a point and a radius. Oh, I see. Actually, we had it right before. See, this function, the error message, let me go. I don't want to go too fast. Look at the error message. Here's the error. Perimeter must return a value. Right there. Area must return a value. So those are the errors. It's refusing to compile. See here, the build, 0 succeeded, 1 failed. So this program failed to build because perimeter needs to return a value. We declared it as returning a double. Let's just return 1. Area, let's return 1. Actually, maybe 0 is a better number. Yeah, it doesn't matter, but maybe that helps debug a little bit. Let's see if that builds. There it is. 1 succeeded, 7 are up to date. Those are the 7 other projects. So we have, we're doing this incrementally, 1 step at a time here. So we're following the book's request, which is to define these functions and do the calculations in those functions that we need to do. So what we'll do is we'll ask the user to specify a circle or to draw a circle. And then we'll display the area. And we'll say we'll compute and display the what's that called? The circumference, right? And then we just put in return 0. That doesn't do much for us, just because we don't want to get a compilation error. This CCC WinMain is declared as returning an int. So this is compute and display. So I'm combining these together. This is compute and display. So first we ask the user to draw a circle. And then we compute and display the area of the circle. And then we compute and display the circumference of the circle. I think does that sound like the right 3 steps to do? Solve the problem? I think that's what it's asking for, right? Aaron, can I see your book again just really quickly? Make sure I'm do this right. Display messages with the perimeter and area of the circle. Thanks. So let's try to display the area of the circle. I think what we did is we used CWin, right? And CWin has a function called message. No, it doesn't. CWin takes a message object. That's it. And the message object takes a location and a double, or a location and or just a message object, another one, or a location and a string. Let's give it a location. Say -5, and the string, we'll say hi. Once again, we just want to get things done incrementally here. There's the hi. Okay. But actually, what we want to do is display this area of the circle. And what's that going to be? Well, that's computed by calling the perimeter function. Oops. Not really the right one to call, is it? There should be the area function. And then that returns a 0. That's our stub code. There's the 0. So there's the area. But we should maybe have the word area in front of that. So let's try doing this. Let's just move that back a little bit. And then print the word area. Oh, that didn't work. I went the wrong way. Maybe make this -6. I didn't go far enough. Let's make it -7. There we go. So you do the same thing down here. And then so that'll be pretty easy to do, right? So we see we have a template here. We can copy that, do the same thing down there. So we'll leave that out for now. How about the getting the user to draw the circle? So that's a two-step process. How do we get the user? I can think of two ways to have the user draw the circle. Does anyone want to give a suggestion on, or to identify those two different techniques? You can ask the user to type in a radius, and then you read in the number. And then you can ask the user to click a point, which is the center of the circle. And then, but did the book ask for something specifically on how the user inputs that? Actually, is this a graphics program? Is there a G next to that? Yes. Oh, okay. What does the book tell us to do on that? To draw the, does he want, the book wants us to draw the circle, is that it?
It doesn't say to draw. It says use these functions in a graphics program that prompts the user to specify the circle.
So there's lots of ways to specify a circle. And you know what, think about it. Where the center of the circle doesn't influence the perimeter or the area. So it's like, well, so that information is not even needed. All we need to know is the radius, right? Just type in R and then compute the perimeter and the area. So doesn't have to be a graphics program, but the book is asking for a graphics program. So how about if we do this? We yeah, let's do it like that. That's a good idea. Let's ask the user to click 2 points, and the first point is the center, and the second point is on the edge, and then we'll draw a circle that goes through the second point. Okay, all right, let's do that. So wait a minute. There's something like get. Is it get mouse? And so here it is. So it's click on the center. Well, it doesn't already exist. Like click for the center. Click in the window to specify the center of the circle. And this returns a point like that, right? And maybe what we'll do is, it's nice for the user to see the point after he clicks on the screen. He or she clicks on the screen. So that would be CWin center. Let's try that. Click in the window to specify the center of the circle. There. Let's see, actually the area doesn't show until there. There we go. Let's break it up. Ask the user to specify a point on the circle's perimeter. Perimeter. And this is the, we'll call it an edge point. Circle redefinition. Oh, I see. We don't need this here. So this is the, here we have create the circle object. I don't know if that needs to be. And we don't need the circle here. Let's just comment that out for now. So we get the center, we get the circle center, and we get a point on the circle's perimeter. Then we create the circle, and then we compute its area. Actually, we need that because it won't build. See here, the code needs a circle. So we're just going to put in this circle here, which is all zeros. Let's try that. Click in the window to specify the center of the circle. Click in the window to specify the circle's perimeter. We're almost there. Now we need to draw a circle around this and compute the area and compute the perimeter, or the circumference. So that means we need the center point. That's easy. This point, when we create the circle, we already know its center, but actually the calculation is independent of the center, so we could have passed in 0, 0. So anyway, let's do it this way. Now we need this radius. We need to compute the radius. Let's say the radius is 1. So we're not, let's wait on computing it. Let's just suppose that the radius is 1. And then when we pass a circle into the area function, it should return the area of the circle. What should the area be? Let's say pi r squared, right? So r is 1, so it's pi. So it should return 3.14. So here's the area function. So this is return pi r squared. So it would be a pi 3.14. 159, I think that's it, times the radius squared. The radius, we'll do it like this: radius times radius. That's radius squared, but we need to define radius. The radius is a double. It's a floating point number. We get the radius out of this circle that's being passed in. And here it is, get radius. That's a function call, so it looks like that. So here's our function. The function gets a circle object. We call the circle object's getRadius function to pull out the radius. And we store the value in this variable that we call radius. We could have called it anything. And then we squared the radius and multiplied by pi, and that whole number right there we return. Look at this expression. This is this number times this variable times this variable. So it doesn't do all three at the same time. It only does pairs of things. So either it does this one first and then gets a result and then multiplies the result by 3.14159, or it does this one first. It takes those two values, multiplies them together to get a single number, and then it multiplies it by the last value, which is taken out of that variable. So does anyone know the order of execution here? We can force it. We can use parentheses and force it. We can say, I want that one done first. Now we know we are controlling the situation. We are saying we want that one done first. But actually, for multiplication, it doesn't matter which one is done first, right? So we could do, there's a principle in math that tells us that those are the same thing, right? It's the, what's it called? The math law, the principle? Huh?
Order of operations?
Is that what it's called? The order of operations? No, it's like multiplication is distributive, it's associative, it's reflexive. Is it called reflexive? Because A times B is B times A. Is that called reflexive? Is that the right word?
It's commutative.
It's commutative. That's it, right? A times B is B times A. That's commutative. Okay. So it doesn't really matter, but here the order of operations is left to right. for multiplication. That's how the compiler was built. So let's see if we get, we need to get, if we set the radius to 1, let's see if that works. One, 2, there it is. All right, so that's working. Now we just need to get the real radius. So how are we going to get the real radius? Huh? H1? The edge point. Well, that's an x and a y. The radius is a single number. It's the distance between the 2 points. It's the distance that's between the center point and the edge point. So how do we compute the distance between the center point and the edge point? We got to know, you have to memorize the distance formula or derive the distance formula. Does anyone know how to derive the distance formula? Yeah, it's like, let's sketch it out. Let's see the distance formula. This comes up all the time. So it's like the square root of x2 minus x1 squared. Yeah, plus the same thing with y. We're going to need another thing like that. So this is the distance formula. If you're an accounting major, you don't need to worry about that after you finish this class. But if you're a math major, or an engineering major, or a computer science major, you got to know that formula. It comes up everywhere. So that's the distance formula. That's the distance from x to y. So it'll be like the distance from x to y, which is the same as the distance from y to x. All right, so let's see, how do we get those things? Well, we have a square root here. And this is a pre-supplied function, square root. I think it's in something called CMath. So we need to include CMath. Actually, the author probably includes CMath, so we might not need that because this header file may include, well, I'll just put it in there. See, this header file here can include other header files, so it might ultimately include a header file that defines the square root function. So we could do, either we type the whole thing in there, we take that formula and enter it into this call to square root, or else we break it into steps. Let's break it into steps. Okay, let's do it like this. Let's call this the x difference squared plus the y difference squared. Where this is the x difference and this is the y difference. So this will be the x difference, so we'll call it the edge point. That didn't help very much. Edge point dot get x. That's a function call. Minus the center dot get x. All right, there's the x difference. Let's do the y difference. Should be get y minus center get y. Everybody agree that that's it? Does that look right? We're stubbing things out. I don't know. Did we finish everything? I'm not sure. Let's, well, we didn't do the circumference, but what about the, we better read through this to make sure we did everything we needed to do. This we're happy with, right? That's the pi r squared formula. We could have defined this distance formula here, this calculation, we could have put that in a function. Actually, let's do that. And then here we create the circle, and that looks good. And here we call it, and then we display the answer. Oh, one more thing to do. Let's draw the circle. That's the... Let's try to make a circle that's less than, that has a radius that's less than 1. So that's there, and this radius, I think that has a radius less than 1, so it's less than pi. Here's a radius that's a medium size, 90. So we have to do the same down here, right? We got to finish it. We get that code in there. But that's essentially it. Any questions about this? Let's create a distance. This is a, let's take the distance from point A to point B. Let's see if let's call that distance function. This is how you simplify or organize your code. This is one way to do it. So the calculations that we did here for calculating the distance, let's just put those in a function that computes the distance from a point A to a point B and returns the number. And now we can call that down here. So this is the we don't need this. Now the circle radius is, we call our distance function from the center to the edge point. Oops. Nope, something didn't work. This is the center. This is the edge point. Oh, you know what it is? This function, distance, is someone else, I think it was Mike. You had this problem, right? The distance function is defined already. And so you're getting, it's very hard to debug this. Essentially don't know what's going on here, but basically this, let's call this my distance, just to distinguish it from their distance. There it is. That succeeded. And that's essentially how you use functions, right? Instead of having all the code glued together, then you can organize it better. In this case, it's just a matter of organizing. But in other cases, you may have a loop, and you have to repeatedly call the same code over and over again. So you could embed it inside the loop, actually, or you can basically call a function inside the loop. So it becomes easier to understand the code, easier to build it, easier to modify it.